Okay, so we're back and we're going to talk about the pulse source in this video. Anytime we want to run a transient simulation or a simulation where we are going to be looking at values as they change over time, which is basically going to be moving forward in this class and in EE221, that's what we're going to be typically looking at. We're going to run, instead of hitting S to open up the SPICE command window and typing .op, we typically are going to open it up and type .tran, and then we're going to type right here, we're going to type how long do we want that simulation to run for. Okay, it's not a physical time. That's not me saying I want my computer to run this simulation for X amount of time. This is saying how much time do I want to simulate for this particular circuit. Okay, so if I want to look at the first 100 nanoseconds of this circuit's behavior, I'm going to look at .tran for 100 nanoseconds. Okay, if I want to look at the first 10 seconds of this circuit's behavior, I would type .tran 10. Okay, so this time here, it's not correlated to real time, physical time that my computer is going to be running, if that makes sense. It's I want to know what is the behavior of my circuit on the screen for this amount of time. Okay, so hopefully that makes sense. So for us, let's just do 10 milliseconds to start. It really depends on the circuit, and so when I do my pulse source, I need to keep this time in mind, because what LT-SPICE is going to do now is it's going to run a simulation, and it's only going to show me a plot for the first 10 milliseconds. So if I were to, for example, come into my pulse source and I were to make the delay 11 milliseconds here, then nothing interesting would happen at all until 11 milliseconds, and then I wouldn't even see it in my simulation. Okay, so these will become more clear as we go, but we typically want to start with some voltage. Let's just say we're going to start at 0, and let's pulse up to an on voltage of 5 volts, and let's delay it by 2 milliseconds. Okay, how long do we want it to take to rise up? Let's say we want it to take 1 millisecond to rise up, 1 millisecond to fall, and we want it to be on for 2 milliseconds. Okay, and then we won't make it periodic yet. This is just going to be a single pulse. Okay, so these are my pulse parameters. What I need to do is I still need to reference this source to ground. Okay, so that my plus terminal will actually behave as this pulse source says that it will, since my reference is the minus terminal, which is 0. And then this net, we can call it the pulse if we want. And now we are ready to hit run. Let me move this over. And what's going to happen on the Windows is it should just open up 2 separate windows for you, but on the Mac it doesn't do it as nicely, and I have to rearrange my screen, which is kind of frustrating, but bear with me. So I'm going to hit run, and now I get this window here. This is my simulation window. You can see that there's 10 milliseconds here. There's nothing here yet. In the plot, they call it the plot pane, P-A-N-E. I'm not sure why they call it that, but that's what they call it. And I usually split up my screen vertically just like this, and I can now click over here on what I want to plot. So if you see up here, it says click to plot voltage V of V pulse. I can click there to plot that. If I want to plot the current, it says click to plot device current. So if we had a bigger circuit, there would be all kinds of options, but for now we just want to plot this pulse voltage. Okay, and then what I'll do is I will add a grid so that it's easier to see what's happening. Okay, so let's check out what just happened with my pulse source, right? We set the start value to be 0, and we can see that it does start at 0. We set the on voltage to be 5 volts, and we can see that it pulses up to 5 volts. We set the delay to 2 milliseconds, and so we can see that nothing happens for the first 2 milliseconds. It just stays at 0, right? We set both the rise and the fall times to be 1 millisecond, so we can see that it takes from 2 to 3 milliseconds for this voltage to rise up to 5, and then it takes from 5 to 6 milliseconds for this voltage to fall back down to 0, right? So that's all the parameters that we just set in this. Oh, sorry, the last one is 2 milliseconds for the on time, right? So we can see that it stays on at 5 volts for 2 milliseconds, okay? So that is the basics of the pulse source. You just kind of go in, you edit the parameters, and exactly what these parameters say they do is what you will see when you run your pulse or your transient analysis on that voltage, okay? And so this is very useful, especially for first order circuits and for simulating, when does my capacitor start charging up, when does my capacitor start discharging, etc. And so in the next video, I guess I'll show a periodic pulse source, or I can show another couple of other parameters like the periodic, setting the period for making this thing repeat itself, and then if we wanted to set a specific number of cycles and then stop it, we could do that as well. And but I'm just going to go ahead and end this video here, and yeah, stop it right here.